Good morning all. I've got some new PCBs from JLC PCB. They're in this box and they're for the Vocoder. So let's take a look at them. There are actually two designs in here. This is one, it's the input amplifier board, which I designed myself. And this is the other one. Now this is a tiny little board and I've called it Jack Daughter, and it's a daughter board for 1/4" mono jack plugs. So let's have a look at this jack daughter board first, because this has multiple uses. So I'm quite keen to see whether I've got all of this right. Let's get rid of all this rubbish. Now the idea is that this takes a 1/4" mono jack. Now I could have designed this to take a stereo jack plug and make it multi-purpose, but I didn't think of that. So it just does a mono jack. Let's get in a little bit closer. So here it is. It's called Jack Daughter, and the layout is really very simple. It's just 4 tracks running from the corner pins to the 8-pin dual inline, well, chip package, but it's not a chip, it's a connector. This is designed to sit in these 4 holes. Let's make sure it does fit. I'm having to look to the side of the camera because I can't get 3D vision. Now for some reason the grounding connections have slightly thicker tags on them, but yeah, that fits in there fine. Good, so that sits in there, and then the 8-pin dual inline sits dead central to that. And for this one I just ran them to the corners, but that kind of standardizes this to a certain extent, because here are the 2 leaves or leafs that run over the top of the socket, and when you put the plug in, of course that's where your connections are made to. So it's these 2 connections which I'll be using on this 8-pin dual inline socket. So if I do another one of these daughter boards for example the RCA connectors, or another one for perhaps a mini jack, I'll probably use the same layout positions for ground and signal. So the first use of this Jack Daughter board is going to be as a 1/4" mono jack socket, or stereo if I make another one of these boards, to breadboard interface. Now I made one of these using Vero board, but of course I couldn't center these pins between the pins of the jack plug. The way I've done it here, I have centered it, but only because I've put these 4/10 apart. Well, a standard dual inline package is 3/10 apart, so by making my own PCB I've now got a 3/10 or 300 mils spacing across here, and it's all dead centered. You can't do that with 0.1" strip board, of course. So if I solder some dual inline pins on here, a couple of sets of 4, and solder the plug on and then trim everything off, that should become a 1/4" mono jack to breadboard interface board, so that I can put jacks on breadboard. So that's the first use of this, but there are a couple of other uses, and they relate to this board. So let's open this package and get these boards out and take a look at one of these boards. So this is my input amplifier. Now this is for the front panel vocoder. I'm actually building 2 vocoders. The front panel vocoder, very much like the original project from 40 years ago, and also a massive sprawling breadboard vocoder which I can tinker with and play with and mess about with. So the issue here was that I need a pot. It's a standard Alps potentiometer, front panel potentiometer, to sit on the top of the board, and then the 1/4" mono jack actually sits underneath the board. So I'll get the front panel to show exactly how that works. So here is the vocoder front panel. Now this input amplifier board goes here, sandwiched between the 2 potentiometers which sit on the top of the board, and 2 1/4" mono jacks which are mic in and line in, which sit underneath the board. And if I turn this round, you can see that when I was using these prototyping boards, which I now think are really very inconvenient to use, and I'm going to abandon that and make printed circuit boards, why not? These little Alps pots sit on the top of the board, And then these jack sockets sit underneath and they have to somehow connect onto this board. Well, you can see from this that there's actually a gap. I think you can see that there's a gap. Let's take the little nib off the pen. Between the tip of these PCB pins on the jack socket and the underside of the board. And I did initially think, well, maybe if I just put like surface mount pads on the underside of the board, I could bridge that gap with a very large lump of solder. But it doesn't really work. So then I thought, okay, let's have the daughter board. So I'm going to put this daughter board on here in place of this jack, and we'll see how that can interface with this, I hope. So here's the idea. We've got the little daughter board sitting underneath the jack socket here. It's a little bit away from the bottom of the printed circuit board, which has the pots on the top, and then bridging that gap will be Arduino style DuPont 0.1 inch pitch pins, which will solder onto the underside of the daughter board. The plastic there should mostly fill that gap. Actually, I hope that it's not too big for that gap. The plastic could always be removed, I suppose, but no, it looks about right. And then I hope I've got the alignment front back. That could possibly be adjusted because there's a little washer on the front of these jacks, so I've got a little bit of forward-backward adjustment there, but I'm hoping everything will line up. And I've implemented both the pot and the 8-pin dual in line to take this and thus take the jack daughter board. I hope everything fits, so I'm going to fit a few components, the potentiometers and the daughter boards, and see if I can get all of this to fit on this front panel. Now, first things first, have I got the distance between the potentiometers the same as the pitch on here? It's 1¼ inches, 1.25 inches. So center of pot, yeah, that looks like I've got that right. So if I solder my pots onto this board, actually I might have to be careful because the pots might have to go in. Oh, that's quite tricky, isn't it? After the daughter board is soldered on, unless I can get my soldering iron underneath the pot. This was the silkscreen outline provided with the Alps, the exact pot that I'm going to use, the Alps pot. Yes, this could be a bit of a 3D trick. Yeah, it should be possible to get soldering iron in underneath that pot to solder the back end of these things onto the no, it'll be the pins of these coming through my PCB. The short end of these goes into the daughter board, don't they? Let's get soldering. So the first thing I'm going to do is break off, that one's bent on the end there, break off little 4-pin arrays from here and solder them into this. But I'm going to use a breadboard just to line these up. Let's not go near that hole I just drilled. Yeah, these breadboards are interesting. They don't come with any holes, so I've drilled a hole in there 2mm, and I've actually bought some tiny screws. I might open them in a minute. They have arrived. 1.7mm, so that I can screw these breadboards down onto pieces of wood for the breadboard version of the vocoder. But let's just get these ones in here first and get one of my jack daughter boards on there. Doesn't really matter which way around that is, but that fits on there, and that will keep all of the pins in a nice square alignment. So while I solder this, I should explain what the third use, I haven't switched it on yet. It's cold, switch it on, warming up. Yeah, the third use of this daughter board is to fit on the back of this board. Now inside the vocoder there are lots of interconnects between boards, and in the original magazine article they just put pins on the edge of the board and you just soldered your screened cable, just brought the center conductor out from the screen and just soldered it to these pins. And I thought, well, that's a bit messy. This is up to temperature now. So I've decided to use pre-made cables as interconnections between the boards. So I want to use phono leads with a plug molded onto each end. So onto these 3 positions here, it's just 3 of the same signal being sent out. I'm going to have another daughter board with the same standard 8-pin dual inline pattern, but with the phono connectors, which I received, which are these white ones. So I need to design a phono connector daughter board with an 8-pin dual inline. so that 3 phonos will sit on the back of this board, 2 jacks will sit on the front of this board but underneath, and then 2 pots will sit on the front of this board but on top. So the jack daughter board ends up being used for 3 things: a breadboard adapter, the front panel jack adapters, and the rear phono adapters. So let's get all of these 8 pins soldered in. Then I can put my jack plug over the top of this because that'll hide what I've just soldered. So I'll have to do it this way around. Right, that's done. Let's have a close look at that. Well, my soldering is spectacularly beautiful as usual. Let's just check that everything's nice in alignment. Yeah, they're nice and square. Yes, that's looking good. So let's put the jack plug on the top of that board. Here's my jack plug, and I put a little mini jack plug symbol on there. The screen print got a bit muddled because I've got a sort of dual inline 8-pin package on there and a miniature jack plug, what I drew. But yeah, okay, that goes on there. Just want to make sure that that sits flat. It's all a bit at a funny angle, but I'll try and get it as flat as I can and then solder it. So let's solder these 4 corner pins, which are my jack plugs sleeve and tip connections, and then also the switch contacts, which I don't think, well, they are used on one of the inputs. In fact, they're both used on one in quite a sort of cunning arrangement. I'll come back to that later. Just need to see whether this and the potentiometers all fit together on that front panel. And then these pins provide for a little bit of height adjustment. When the pot is soldered onto the top there, the jack plug can be raised and lowered before I solder it, so that the pot and the jack plug fit the 1 1/4 inch pitch top to bottom. It's 1 1/4 inch in all dimensions on that front panel. Let's get a pot and just give it a try. Right, 10k log for the volume control. That is this left one, I believe. Oh yes, I've actually written it on there. 10k log. Oh well, that saves me looking at the circuit diagram. And 47k lin for this one, which is the tone control, where you can twist it between treble and bass. Right, let's see if I've got those pots. So I've had these for some time. They all came from Tader. I've got 100k log, that's for a different part of the vocoder. There are my 10k logarithmics and a couple of 50k or 47k linear. So yes, I need these 2. So 10k log is the A10k. A is the logarithmic profile or track thing. I did a thing on log pots. They're not very log. They're kind of almost like 2 parts of a track, one with a slightly different value to the other. Yeah, they're not really very continuously logarithmic, but anyway, better to use log than lin. So that will sit in the top there, and then the socket will fit on this 8-pin dual inline and provide me with my, now are they matched on the front panel? They do look like they're going to be matched. And then I'm looking for that 1 1/4 inch spacing between those 2 with that sliding. So I guess I should solder the pot in first and trim those little legs off. Then screw it all to the front panel. I'll need to break that little tag off. They're very easy to break off. It's just cast aluminium. In fact, let's do that now. Get my pliers on there. And that just breaks off really very easily indeed. And then that will fit onto my front panel. Now actually there are 2 of these input amplifiers, because there's another one which takes sort of synthesizer low level and high level input, and it fits on a slightly different part of the panel. It's over here, I think. So what I could do is I could experiment with getting these 2 through the front panel, seeing if the pitch is right in this position. Let's do that. Oh no, I can't do that because these holes are the wrong size. I haven't reamed them out. I have reamed these ones out. So I'll strip this down and I'll work on this end. Now there's a very slight alignment error here. The socket won't fit flat to the panel because the board length is slightly too long. It's fine for the pot. I've got that exactly right for the pot, but the jack socket tips the thing over when I push it to the front panel. Now this may not be a problem because the jack socket comes with a little washer, which I had on the outside, but which actually probably looks better on the inside. So if I pad the jack out with this washer, it should bring the PCB slightly away from the front panel. There's also a very thin washer, this metal one, which I can put behind the pot, which will bring that slightly away from the panel. That might just bring everything into alignment. I'll give that a try. Well, yes, it's a spectacularly good fit because everything is now fitting wonderfully. The PCB is ever so slightly away from the front panel. I can wiggle it around. It can slide in and out on the pins on this jack plug. The pot's a good fit. The only trouble is, having moved this little washer, this little thing, to the back, there's going to be no washer on the front to prevent this nut chewing itself against the powder coating on the front of this panel. But the alignment's great. I just wonder if I can get away with not having that washer, or do I buy more pots in order to get more washers, or shall I just try and source some washers? Maybe that pot would work just as well without the washer. Just give that a try. Yeah, it's not quite so good without the washer behind the pot because that tips. Nothing quite fits. If the pot is flat on the back, then the jack plug isn't flat, and if I try to flatten that, it lifts the pot. So I'm just wondering whether a slightly smaller washer under the jack plug might work. And I do have this, which is a set of fibre washers and O-rings and all sorts of stuff. I'll play with that for a bit. Right, yes, I found a combination that works. That fibre washer is just right. No washer behind the pot, and then the pot and the circuit board fits in there, and everything aligns and is flat. That looks good. And then I'll put the plastic washer on the front of the jack plug, or I may not bother. But it does mean I have this washer on the front of the pot so that the nut won't start tearing into the powder coating on the panel. Okay, I think it's time to solder in my 10K log pot. So here it is, piece of blue tack under there. Let's get that in and get it absolutely square. Square to the front and square to the side. Make sure I've got that absolutely right before I solder it, because these through-plated holes make it quite difficult to remove something. There's a little bit of bendability in the leg, so that alignment is not hugely critical. Let's solder that. So I've gone for a copper fill again on the back, but I took the margin out. I can't remember what it's called, the clearance I think it is. I slightly opened that out so that the spokes on the grounding points are effectively a little bit longer, so I'm having to have slightly less problems with heat being sucked away on the ground pins. I'll know on this near one because that's a ground pin. Let's just clean the tip. Okay, let's solder that one, which is probably the signal in. This is probably signal out on the wiper, and this is ground. How well does that solder? It still is a little harder, and you have to leave it there a little bit longer, but yeah, that's not too bad. That's gone on. Cool. So that's my potentiometer on there, and then when I come to put the jack plug into the 8-pin dual inline thing, I've got my alignment ability there. They're lined up one exactly under the other, and I should be able to get under there and solder those 8 pins. So that's the second pot soldered in, all beautifully aligned. Do those fit through the front panel? Let's try them. They go in there. Oh yeah, look at that. Perfect alignment. 1.25" between those. So I want to fix those on roughly centrally and then get my jack sockets fitted underneath. Beautiful. So what I'm trying to do now, these two jack plugs are quite a tight fit in their holes because they were reamed out to take the jack plugs because I slightly underestimated the size of those holes. The pot holes are slightly too big, if anything. So I'm just trying to align everything so that these pot shafts sit roughly in the middle of these holes. Then I'll clamp those down with the washers and nuts, and then I can solder these 8-pin dual inline arrays into the circuit board so that everything then is in perfect alignment. Then I've got to assemble the rest of this board, which I've made slightly difficult for myself because some of it's kind of under these daughter boards, but it's not too bad. I can get to everything, that's no problem. And with everything in perfect alignment, now's the time to solder these pins as they protrude through these boards. I suppose I could just solder a few of them while it's attached to the panel, the ones that are easier to get to, and then do the others when I remove it from the panel. I'll do a couple of these ones right under the pot, so I can see that one reasonably well. Can I get to, and I'll do the third one back. Don't think it's used, that one, but what else can I get to? Can I get to that? Probably can. Right, that's probably enough to anchor everything in place, so I can dismantle all of this now and just solder those remaining pins. Just soldering the remaining pins that I couldn't, there's more, not that I couldn't get to, I couldn't see very well when they're on the panel because it's quite dark. I can see a bit better here. Some of these are a little buried, but you know, this is a 3D spectacular and it's not going to be easy. It never was going to be easy, was it? Just got to be careful not to melt these plastic covers on the pots. Oh right, the last two are the most difficult. I've got this one under here. Let's do that one. I can barely see what I'm doing here. And that one right under there. That's a little better lit. Just let the solder flow down through the hole. And I think we're there. And this, well, it's a thing of beauty, isn't it? We've got the pins sitting just above the board. And it's a 3D spectacular. Yes, it needs these fibre washers, but and I need to remount the inside of them slightly, but that makes the alignment of all the fronts absolutely on axis. And yeah, there is my pot and socket spectacular. As I say, that's going to make the assembly of all the other components slightly more complicated, but I'm willing to suffer that just simply to see this. Oh, I've got to pass this back through the front panel now. Right, let's do this. Now I deliberately didn't over-ream the two holes for the sockets, so they're quite a tight fit. They go in like that. Oh, that is a beautiful thing. Yes, look at that. That's a joy to behold, isn't it? And the board is just fractionally off the front panel. It couldn't have been better, really, in terms of accuracy. Yes, I'm very happy with that. And then, as I say, the output from this amplifier board, there is only one output. You can see these three connections are commoned. That is the output line, that track there. Now, I'm not going to put jacks here, and they're too closely spaced. The jacks wouldn't fit there. This is going to be the RCA phonos. So 3 RCA phonos will sit on little daughter boards again, so that I've got 3 outputs from this board. And that makes this board a self-contained, useful amplifier, whether it's part of the Vocoder project or not, because you can plug your microphone into there. You've got a volume control, some gain afforded by the 2 op amps there, and the output comes out on a phono, so I can plug that straight into another device or an amplifier, and this will work as a standalone module. This is a JST here for power. It's 12, 0 and -12. A couple of capacitors there. That's all looking very pleasing. And then there's the added bonus that this little daughter board also works as a jack to breadboard interface. So I can take my jack to breadboard homemade Vero board interface off this, which is also the input amplifier, but this is for the breadboard vocoder. This of course is for the front panel vocoder. Two different vocoders. Oh, it's exciting, isn't it? I can plug in my new professionally made jack daughter board, which interfaces the jack plug to the breadboard. Well, I think I'll power this up. I've added a VU meter here. Yeah, let's see if that works. Let's put some power on this power supply. Yep, we've got a little burst of activity on the meter there. Right, let's plug the microphone in. Oh yes, we seem to be getting... yes, that works fine. That's my little VU meter. Can I send that up to the top of the shop? No, but that's an issue with this circuit and the tone control, and I'll have to deal with that another day. Actually, maybe I'll deal with it now. Well, just briefly then, if I turn this tone control fully round to the bass boost, I can get that to go up into the red. I can get the red LED to come on. I don't know whether you can see that. Yes, the red LED is coming on. Now if I turn this round to the treble boost, then it goes barely over halfway, and doesn't matter how loud I shout into the microphone, I can't get the upper yellows or the reds to come on. So certainly this level meter seems to be more sensitive to the bass tones than the treble tones, but I'll come back to this another day. So that's the input amplifier for the front panel vocoder done, and that all seems to work fine. I do need to make up the little RCA phono socket daughter boards to sit on there. I might have a play with panelization for that, because they are going to be very tiny boards. I'll see if I can get them made with score lines so that you just break them apart. But yeah, 3 of those phonos will sit on there, and then they go off to different parts of the vocoder internally. The output mixer, the analysis board, and somewhere else I can't remember. I've already started, I'm really enjoying actually designing these printed circuit boards. I've already started on the output mixer amplifier, which is a wider board. It has 4 pots, 2 sockets again. I think one is for a foot pedal for the freeze and slew rate controller. So working on that one. That again will be standalone. It will have, now actually that one's not going to have phonos because I need something like 16 socket inputs. So I'm going for stereo mini jacks on that one, just to complicate things a bit further. But yeah, my input amplifier is an absolute 3D beauty, isn't it? Lovely. Cheerio.